the three main initiators of the PPRS event itself. I hope you've had a successful few days so far. It's certainly been a very busy program, I know that for sure, long days, but and also maybe you've had a little bit of time to enjoy the beautiful city of Nice. I'd like to thank actually the team at IBEF for inviting me to chair this session. The session is entitled World of Bitumen Emulsions, an industry serving sustainable roads. It's a pleasure to be here. I know a lot of work has gone in making this happen, so thank you to everybody involved for putting in this effort, and also to all the speakers we have this morning that are going to keep you animated for the next 2 hours, even though it's very warm in this room, I can tell you. I'd also like to take the opportunity just briefly before we start the session to remind you all about a little bit about IBEF and the mission. So the International Bitumen Emulsion Federation, it's a platform dedicated to bringing together associations and organisations within its membership that are specifically related to bitumen emulsions from all around the world. It's committed to promoting and continuing the best use of emulsions, sharing information on experiences and best practices related to standardization, technical performance, health, safety, environment, and development of bitumen emulsion applications. I know we had a great session yesterday in the Angora seminar. This morning you're going to hear more examples of best practice and sharing of information. So for those of you who don't know me, I was the acting president of IBEF for the last 3 years, but I actually ended on Sunday. I handed over my role to Galen Baumgardner. I can't see Galen, is he here? Are you here, Galen? No, not yet. So Galen actually represents the Asphalt Emulsion Manufacturers Association in the US. So I was elected president 3 years ago at the very first PPRS in Paris, for those of you that attended that. I've learnt a lot. I think together we've achieved a lot, and I would like to thank again everybody in IBEF for the support that they've given me over the last 3 years. But going forward, I'm sure that during his tenure, Galen will also be able to continue the excellent work. So, for the next 2 hours, we're going to be looking at a very special world, that world of bitumen emulsions. For me, it's really important to have this focus during the PPRS. Out of an estimated figure of, let's say, 100 million tonnes of bitumen produced across the world every year, approximately 8% goes towards bitumen emulsions. It doesn't sound a big share, but I mean, despite this relatively small proportion, bitumen emulsion continues to provide extremely cost-effective and flexible solutions for sustainable road maintenance globally. This very positive message should be communicated, or dare I say even shouted about, because we should be telling this very special message every opportunity that we have, especially in this current environment that we're working in. The poor state of the national roads and the pavements is a big concern, especially in Europe. So it's vital to look after and maintain our existing road network with a focus on sustainability. This is where bitumen emulsion can play a very important role in the overall toolkit of solutions used every day by highway engineers. So, there will be a continued demand for bitumen emulsions, I'm sure, and we maybe hear a little bit about that at the end of this session from Etienne. This is why our industry matters. This is why we, as emulsion advocates, need to shout about this. So the task of shouting about it will go now to the five presentations that we have. Some of them are being shared by with 2 presenters. I will remind the presenters we have approximately 20 minutes for each slot. We'll try and keep to that so that we make sure everybody has the opportunity to share their own experiences. So the first presentation is going to be one of the shared ones. We have Bernard and Gail that are going to present. So I would just like to pass you over now to Bernard to kick off this special session. Thank you.
Thank you. Thank you very much, Siobhan. Good morning, ladies and gentlemen. We'll try to be as short as possible in answering the question of whether EN 13808, which is the European emulsion standard, if it will ever be a performance-related standard. And to try to answer that question, we will first explain the background, show EN 13808 how it is today, make a critical evaluation thereof, some proposals on how it could be improved, and finally come to the trying to answer the before mentioned question. Background is, in fact, the European Construction Products Regulations, which applies to all EU member states, and of which the main objective is to remove barriers to trade while giving construction products, putting them under the so-called CE marking process. And an underlying driver for this is that construction works must satisfy a set of up to 7 basic requirements. To enforce this regulation, the European Commission has given mandates to the CEN, which is the European Standardization Committee, and in the case of road construction products, it's mandate M124, which identifies the basic requirements which have to be considered for bituminous emulsions. The task of the CEN technical committees is then to propose the so-called essential characteristics and test methods by which you can fulfill those basic requirements. And that's the so-called answer to the mandate on which finally the product specification has been built on. This is an example of how it looked like. This is finally the mandate, and it says here, you can see, you have some requirements on the emulsion, viscosity, and so forth, and mainly mechanical requirements on the residual binders, including durability. That brings me to the description of EN 13808 and to explain you what these essential characteristics are which have been identified in the answer to the mandate. Some of them are relating to the emulsion as such, like viscosity or breaking behavior. We are the so-called filler tests. Most of them relate then to residual binders, and it's mainly requirements on consistency in relation to temperature, and also cohesion for polymer-modified binders. Nevertheless, there is a refinement in the sense that these residual binders are to be considered at different stages of the emulsion life. The first one being, of course, the product once it's on the road. You have sprayed it, laid it, you get the water out, and this you try to reproduce via a so-called plate curing test, and this binder is assumed to be the initial binder just once on the road. And then you enter into 2 possible stages for durability. The first one being a stabilized binder, which is obtained by just continuing the previous procedure by a further day at 85 degrees C. And the stage 2, in which you long-term age the binder via the well-known PAV process. Unfortunately, so far there is not much experience on this one. Beside those essential characteristics, the EN 13808 standard also includes so-called voluntary characteristics, of which some are not directly related to the mandate, even if they may be compulsory, like binder content or sieve residue. Others may be just selected at a national level, such as storage stability and settling tendency. And funny enough, there are also some voluntary characteristics which have been introduced and which in fact should be related to basic requirements, even if they have not been identified in the answer to the mandate. That's, for instance, the case for low temperature behavior like fast breaking point or cohesion or like elastic recovery. And this brings us to a standard which has another particularity in the sense that it's not looking like a normal product standard in which you identify each product through a column each column corresponding to a product. In this case, what we have is the different requirements which are part of a final table. Requirements, each line corresponding to a requirement, and for each requirement you may have several classes of performance, and a producer may then identify its product by telling to which performance class it belongs for each required property. This has a result of the wish for harmonizing all what existed in Europe. And that was the only way to come out with a general consensus. Now we can, of course, be a little bit critical about the EN 13808. And one has to say that we can identify that there are, in my opinion, some structural shortcomings, in the sense that the difference between voluntary and essential characteristic is not that clear. For instance, binder content and sieve residue, in fact, it's very important. However, it's not mandated. And we have also introduced some characteristics which seem to be voluntary, or when they should have be part of the answer to the mandate and considered as an essential requirement. And in addition to that, the problem is that for each essential characteristic there is a possibility for several test methods. That was also a result of the necessary need for a consensus, but it's not according to the initial rules, which normally say that there should be just one test for each essential characteristic. And that explains why there is so much flexibility in the standard, for instance, with the possibility to have the no requirement performance class, so that people are not obliged to do something which they are not used to do. So in this sense, EN 13808 is indeed really a framework, but it's not a product standard in the sense that it gives straight and well understood guidelines. And because of that, we could say that it's not really a very strong help to the painting industry for promoting emulsion technology. And another problem is, of course, test methods. I will not go into the detail, but many of them might be seen as not necessarily fully relevant. For instance, breaking test with filler. Many of them, and if not all of them, suffer from poor reproducibility and are often blamed for that. And in relation to the goal of performance-related specifications, these tests are also still empirical rather than fundamental. Now you can say, what are you doing? You should do something about it, you should improve it. Yes, of course, there are possible ways to improve it. And we had some kind of a thinking exercise in our committee and came to some ideas which are well understandable. The first one being that the structure of the standard should be changed and specifications related to more specifically related to intended uses. And that would also allow that essential characteristics would be better defined in relation to the intended use, and which would be, of course, much clearer for producers, contractors, and road owners. We would, of course, keep the distinction between recovered, stabilized, and long-term aged binders, as well, of course, introducing some additional operational parameters, such as, for instance, sieve residue storage stability. That's, in our opinion, essential for producers. And just a few words about defining end users. Of course, you can easily say there are emulsions for surface dressings, for tack coat, and so forth. But it's not enough to just say that. I think it's more important and interesting to identify for each of these applications what are the requirements it implies for the emulsion as such, and the residual binders. And if you do that exercise, and we have done it for spraying applications and coating applications, then you can end up with a real specification table in which for each type of emulsion you identify what are the really relevant characteristics. And as you can see here, certain characteristics are not necessarily needed for all kinds of emulsions. And that is what would make a standard much more dedicated to what are the applications and what are the real needs. However, this will not work if we don't also work on improved test methods on the emulsion as such. I was speaking about the relevance of braking behavior. Efflux time, for instance, should be replaced by dynamic viscosity measurements because it allows you to take into account strain rates. And of course, characterization of residual binders, as Dr. B.ECKMANN will explain you later on, should be done via fundamental tests rather than empirical tests. So there are possible ways to improve. Will we be able to do that? That is my last two slides. So will we ever get to this? Of course, we can say that European harmonization does indeed consider performance. We have been speaking about basic requirements, essential characteristics. The problem we are facing now is that these requirements have not fully been answered, or not adequately answered, in the sense that there is insufficient consideration of end users. We have not the right methods. The problem, however, now is that since the driver of the standard is not so much technical, but the first objective is to alleviate barriers to trade, we will now face important difficulties to introduce new essential characteristics and new test methods, since the European Commission is likely to consider those as an imposed new burdens to producers. And so in order to be able to introduce that into the regulation, we will have to bring the Commission to issue so-called delegated acts. And this is a process for which we don't know exactly how it will work and how much time it will require. And unfortunately, we have not yet been given the kind of silver bullet by which could help us in getting out of this quagmire of regulations. And finally, there might be, as you will see, limited money available in the US. The problem is that in Europe there is no money at all, meaning that there is no pre-normative research on emulsions which could allow us to have better test methods, and there would be even less money available for validating those methods and those performance criteria against in situ behavior. So in Europe, we should be optimistic about getting some progress. However, we have to be very conscious that it will be difficult, first because we need to convince member states and EC to agree on new performance indicators. And second, I think it will only be the paving industry which will be able to invest and find the necessary resources to develop better and more ad hoc performance tests. And by this, I thank you for your attention. I leave the floor to B.ECKMANN for much brighter perspectives in the USA. Thank you very much.
Thank you, Bernard. I'll be trying to summarize in 10 minutes about 4 research projects, each of which were worth about $1 million, and about 10 years of work by the Emulsion Task Force to try to advance the effort to create performance specifications in the U.S. We're kind of on the back stretch on this. Our first goal was to have a chip seal performance-related specification in AASHTO format to AASHTO by, if possible, this fall, maybe next spring, and all the work that's going on to try to make that happen. So things are moving forward. Just a few of the topics, a quick view of super PAVE and PG specifications, the things that are driving our move towards performance specifications. I'll be talking mostly about purchase specs for emulsion materials and particularly emulsion residues and how we see those materials being tested and specified in such a performance graded system, as well as where we are with AASHTO right now, which is working with antiques. The Emulsion Task Force that drives this process and who's funding it, kind of a cohesive plan overall of how we see the entire system going for at least 12 different emulsion applications. So my talk and our work is mostly chip seals right now, but the process has to include many other materials as well that will ultimately fit within the same test equipment, same test methods, same recovery methods, and same system. And finally, as far as I can go before Madam Chairman pushes the trap door and makes me disappear, I do want you to know that page 46 of the RGRA book you received, the February-March edition, has Bernard's introduction to his work, and my work is on page 54. So for all the technical details, I will skip. Please refer to this. So with that, the SuperPave, of course, has a PG binder specification, and that's what we're really trying to replicate primarily, but recognize we're also trying to do all the other things that are part of a performance system, that is the mixed design requirements and the performance testing. In the case of SuperPave, the mixed design uses a SGC gyratory, taken much from the French system with the press gyratoire. The performance testing, initially it was rutting, stripping, thermal cracking, fatigue cracking. We've added an additional performance criteria. We found out that the surface aging is a different failure mechanism, and we're looking at new specifications in the direction of changing rheology to understand brittle failures. You can see some of the papers by myself or Jeff Rowe that talk about that. So some changes are coming, and the test methods are also changing over time. But the important thing is the failure criteria, what we're after in performance is what's important. If you define the failure criteria for an application, then you can choose and adapt the test methods to fit as best you can with the failure criteria you're trying to match. For example, in the binder specification from the hot side, we've got the Brookfield for mix and compaction temperatures, a dynamic sheariometer test at high temperatures to define rutting that's now changing from the original G-Sine delta to a massacre multi-stress creep recovery test. So the tests are changing, but the tool's the same. The software is different. Intermediate temperatures, we had a parameter called G*Sine delta. It was supposed to be a fatigue parameter. After 20 years, we found out that didn't work, and pavements are cracking because that allowed too much recycled engine oil, and that was a really bad thing. And so that's one of the things we're working on, trying to understand cracking in the context of rheology. And with black space, we're getting there. And you can refer to some of those papers elsewhere. And at low temperatures, originally we had bending beam rheometer and direct tension tests, but we're finding out that we can run dynamic sheariometers now with 4mm plates and get the same low temperature information for rheology. We can run dent tests and other things that are more convenient than the DTT to get failure strain. So the tools are changing, but we're after the same physical properties. We're just trying to make the tools easier and more reproducible so we can put them into specifications. Of course, for emulsion specifications in AASHTO, and our committee is supporting AASHTO, the Association of State Highway Transportation Officials. This is not ASTM specifications. And AASHTO has 3 emulsion specifications, one for anionic, one for cationic, one for polymer, for slow setting, medium setting, rapid setting, quick setting grades. If you go into the emulsion test laboratory, you see every bit of that equipment is 80 to 100 years old. We need to take a sign that says antiques from asphalt testing and isolate that lab as a museum and start over with new emulsion tests that are more pertinent to what we really need to find. So I'm not going to talk about what we do now because it's really inappropriate to performance testing. The Emulsion Task Force was appointed by FHWA, but now is being supported by AASHTO, the TSP2 program. And it's just a group of experts led by Larry Galehouse and Jim Moulthrop and others, but at least 2 members in this room that have really been the drivers to make this happen. And initially, we're trying to just take all of the AASHTO specifications at all levels, material specifications, design, performance, construction specifications, and just rewrite them and bring them up to date. And that's mostly been done. But the primary effort then was to develop performance specifications and design standards for all emulsion treatments. So far, we've identified 12 different emulsion treatments in that category. And what I'm going to talk about primarily is specification for materials, that is the emulsion specifications both for the liquid emulsion and the residue. First, to do this new system, we have to start with a plan that anticipates how we're going to envelop a system that includes all those 12 different applications. We have to have one single common residue recovery method. And it can't be the distillation method of the past at the really high temperatures. We want a recovery method that is at a temperature that is similar to what we have on the pavement. And in fact, the Europeans are far ahead of us with the 50-degree forced draft oven, and we're using 60 degrees instead of 50 degrees. We're using very, very thin film that gets us residue in 6 hours instead of the 48 hours required for the European method, so we can turn around information faster, and that's primarily because we're turning over emulsion tanks every day when there are chip seal crews coming through. We can't wait weeks for this information. We have to find ways to speed up our recovery process, and this is one way of doing so, but it delivers very little material, because the film is thin, so we can get the water out, but that means we don't have much residue to test. So all the tests we currently use don't work anymore because we don't have enough residue, and we don't want to heat and pour the residue. We want to test the residue as it cures. That's at 60 degrees C or less. So now we have to totally rethink everything we're doing to test residues and specify residues in the context of the recovery method that gives us a limited material, and we never want to heat over 60 C. So we are developing test tools to do that. And the DSR is perfect because we can wad off a little ball of our recovered residue without reheating it, put it on the DSR and condition it and test it. But we're finding we can do many more things than frequency sweeps with the DSR. We can use creep recovery tests at multiple stresses if we like. A 4-millimeter plate geometry now allows us to replace the bending beam rheometer and define low temperature rheological properties with our rheometer. We can determine now brittle behavior. For hot mix, it's about this surface cracking, and we're using parameters like the Glover-Rowe parameter and delta TC and things that are now showing up in the literature for cracking, but also for brittle behavior and aggregate loss at low temperatures. Same sort of thing. We can define that brittle behavior with the DSR. We don't need a frost test or some of the other tests we've traditionally used. For PAV, we're trying to decide if we need PAV aging for emulsion residues. We're not sure, so we're testing materials with and without aging to try to understand whether aggregate loss over long term is due to asphalt aging for chip seals, for example. And finally, Brookfield viscosity, we're using the multi-shear rates that my esteemed colleague Bernard discussed earlier to try to understand different things. Thank you. This plan then has to look at each individual application and understand what are the performance criteria. For a chip seal, for example, it's bleeding and aggregate loss. Each of the other applications, cold in place, cape seals, fog seals, whatever, each has its own performance criteria that have to be defined. We have to develop the test methods and tools and the threshold values for specifications for each of those. And finally, we have to figure out how climate and traffic figure into this. Remember, in performance, rheology is temperature dependent and climates are temperature dependent. So either the threshold values or the test conditions have to adapt for the climate. And that's the primary key to performance-graded systems that are not in our system at all right now. And finally, we need to validate and implement, and we also have to do all the mixed design performance testing on the emulsion side that we did otherwise. I'm not going to talk about that because that's not part of emulsion purchase specs. So for chip seals, where are we? First of all, we're trying to develop lab tests that are performance tests for chip seals. We have bleeding, so we have Richard Kim used an MMLS3 traffic simulator to simulate traffic, and then he has image analysis to determine how much bleeding you get for different application rates at different temperatures, for different materials, when you use polymers, more traffic, whatever. All the performance criteria, he can measure image bleeding, and therefore we can make decisions on the rheology of the material at high temperatures where that bleeding doesn't happen. Same thing for low temperature with aggregate loss. He's looking at a number of tests, including the violet ball drop test. And we don't know if we need moisture damage or not for chip seals, so we can condition that ball drop test material with moisture. We can do it dry. And we can now try to understand what performance is before we then try to develop our test methods for the binder to simulate and give us the performance we see in these mixes. Construction time to traffic is important. Sweep test is one good thing. We can run the sweep test after however much time we allow it to cure after we apply the aggregate and get some idea. That's especially important for when we use polymer modification for heavy traffic, for chip seals. And finally, the aging issue, again, really struggling with whether we need a PAV long-term aging test for residues or not. 4 research projects to refer to, one headed by the National Center for Pavement Preservation, done for FHWA and federal lands, looking at different possibilities for test methods, a chip seal best practices study from NCHRP that developed field emulsion viscosity testing because we feel it's more appropriate to test viscosity in field as materials are applied, and then 2 specifications for chip seal residues that have been turned into AASHTO already from 2 different research projects. TxDOT spent over $2 million developing their own system that they're using now for all of their chip seal projects, and an NCHRP project done by Richard Kim and Hussein Bahia at North Carolina State and University of Washington. Those reports are all out now, many publications, and in this case, we're talking about SPG in the case of Texas, surface performance graded specifications, or emulsion performance graded specifications, EPG. It's 2 different solutions to the same problem with totally different tests, looking at the same damage models and try to simulate those with different test methods. We're now trying to run a round-robin study of materials across the country to sort some of that out. Of course, a performance system is based on climate, so we start with the climate maps and the pavement temperatures. One thing you recognize is for hot mix, all of our criteria use depths 20 inches in a pavement, but chip seals are on the surface. The pavement's 3 or 4 degrees hotter, so the grades change. There are a lot of different emulsion properties. Richard Kim's developed the methods to look at shear rates in pumping during spraying, and finally the shear rates on the road, whether material runs off the road into the low areas or whether it stands up for cracking. So we have a much better perspective, as Bernard suggested we need for using shear rate on emulsions. Storage stability, totally different things. We're looking at the top and bottom to see if we get sedimentation, but using the toothpaste tubes we typically use for polymer modified materials. Also looking at what materials look like after a period of aging in the oven versus before on average to see if we're getting any flocculation of materials. And so it's both sedimentation and flocculation coagulation during storage we're after. And emulsion properties look something like this. Residue specifications, looking at bleeding, aggregate loss, how many grades do we need for traffic? This is a really big issue because we currently have modified grades, polymodified and unmodified. We have 2 grades for any climate. The research is proposing we have 3 grades, low, intermediate, and high volume traffic chip seal emulsions. The suppliers just want 2 because it's a lot of tanks, a lot more storage. So there's some issues here where the entire industry has to buy into this. And we're going to EMA and trying to get EMA buy-in as well as other things to understand whether some of these decisions the researchers tell us we should do is in fact implementable by industry. So it's a joint effort. In this case, for EPG, there is no PAV aging. And this is what the residue specification looks like. It's in the paper. I won't go through it. The SPG, the Texas work, they're looking at G-star over sine delta rather than MSCR. So they're using DSR for bleeding, but 2 different tests. Aggregate loss, they're using stiffness of materials, whereas the EPG specification initially used a single-edged notch beam and was looking at fracture properties. Now they're changing to rheological properties, but they're using the DSR rather than the BBR, and they're bringing phase angle and brittleness into the context where the Texas specification does not do that. So we have to decide among these options, as well as others being offered us, which might be the best failure criteria. Everybody's after the same failure. It's the test methods we have to judge which delivers the right answer. This procedure includes 20-hour PAV aging on the emulsion residue before we do the low temperature testing for aggregate loss, whereas the EPG system from North Carolina State did not. So more differences to work out. This is what the Texas spec looks like. There are a lot of questions and challenges, decision points. When do we use polymers? Is it traffic driven? Is it when we use snow plows and we need more fracture toughness? How do we specify polymers to make sure there's polymer in the emulsions where we want them? We use a lot of high float emulsions in the U.S. We have to find high floats with a DSR, not as we traditionally have done. Dr. Dave Anderson is helping us do that. Should low temperature properties vary with traffic? As well, in hot mix, we only vary high temperature properties with polymer modification. We're not sure if low temperature properties should vary or not when we add polymers. Aggregate loss, all of many, many issues. Again, most of those are
Gail,
in the paper.
can I just interject? I mean, is all this information in your article as well?
All but this
all
last
this?
slide, and that's just
Perfect,
what I want to finish
perfect.
with. So we have a big residue testing program going on right now. We collected emulsions from all over the country to test, and this is one sample, has all of this test information to help us answer some of those questions. And finally, in terms of what Europe is doing versus what we're doing in the US, what we find is we're after the same damage. It's just the test methods we're using that are different, and the closer we can come to doing the same thing and using the best available test methods and using rheology, the better chance we have of being successful. With that, thank you, Madam Chairman.
No,
I ran
thank
over.
you. There's a lot of information there. Thank you, Gail. I think just reinforce the fact that I think on most of the information is in more detail from both Bernard and Gail in the publication, which I think you can get outside, actually. I think there's got to stand right outside the door. So I'll move on, actually, to the next presentation, then we'll see how much time we have after the next one to see if we can ask for any questions in the audience. But I would like to invite Larry up on the stage to continue the discussion, and then we'll see if we've got a few minutes after this presentation to